Thank you, everyone. Appreciate you jumping on the call. Good morning, good afternoon, wherever you are in the world. Today we're going to be continuing our series looking at Forge Extensibility in Bitbucket Cloud. The session today is going to be, we're going to try and keep it a bit shorter. We're going to try and keep it within the hour. So the component where we're running through the app that we've built will go a little bit faster. And that will leave us some time for Q&A at the end, hopefully we'll start wrapping up before the top of the hour. So I'm not going to go too much into it before. We're just going to jump straight into the code. If this is the first one of these that you're watching, I strongly recommend going back and having a look at some of the earlier in the series that we've run. We run 2 on custom merge checks so far and 1 on dynamic pipelines. They're kind of your intros to the whole topic. They show you how to set up a new Forge app. They explain sort of the context and the concepts for you. This one today, we are going to just jump straight into it. So if this is your first one of these, you might feel a little bit out of your depth. But rest assured, everything we're going over here today is stuff that you can sort of catch up on within a few hours if you just go back and have a look at some of those videos. The app that I'll be walking through today is one that I built a few days ago. Context, this took me, I want to say, 3 to 4 hours to build, just to sort of give people a kind of perspective on the complexity of building these things. But it was a concept that was sort of new to me in terms of building. So I think now that sort of I understand how to do it, it would be sort of a fair bit faster, but just gives everyone sort of a frame of reference for how long it takes to build these capabilities. So what we're going to be looking at today is a way that you can improve the cycle time of your pull requests. So a way to get the end-to-end time of pull requests down, allow your teams to move faster, allow you to be merging more code. And the way we're going to be looking at doing that is through intelligent test execution. So what we mean by intelligent test execution is if you're in a large repository which has been around for a while, hopefully you've got a lot of tests. Some cases you might have literally millions of tests, and those tests take a really long time to run. And so what we're saying, as TDD and test-driven development rose to prominence sort of over the last 10 years, hopefully a lot of teams now have got a lot of tests in their projects, but those tests take time to run. And so now we're starting to encounter situations where teams maybe have so many tests that the builds are taking a really long time to complete. There are ways you could address that through things like test sharding, where you split your tests over multiple parallel steps. But that's quite a bit of work to actually go and implement. Stay tuned on some interesting stuff we're bringing to Bitbucket Cloud around that in the future. So other ways you can try to sort of optimize your builds are things like selective test execution. So what selective test execution is it's when you basically look at the changes on a pull request, for example, and you pick which tests are going to run based on the changes on the pull request. So rather than running every single test on every single PR, you might only run the tests that are relevant to the files that changed in the PR, so that at least your branch builds can build faster. And then maybe only on your, say, your builds and deployments to production are you going to run every single test in your entire repository. And that way you could sort of like increase the efficiency of your workflows a little bit. Now, obviously, there's a trade-off to this because you're not getting full test coverage in every single run. But depending on the size of your repository and the number of tests you're doing, it quite often is worth it, particularly if you're in a larger repository. The main thing that we're looking to show today, though, is more the concept, the idea that you can look at a pull request, you can look at the files that were changed on the pull request, and you can do something based on that change, whether that's change the pipeline or do anything else. Whether you use it for selective test execution or whether you use it for something else is completely up to you. The selective test execution is just a nice example use case that we can show you all today. So with that, we will jump into it. I'll share my screen. Give me 2 moments. All right. So unlike the last time, we're not going to build the entire thing live. I learned my lesson last time when I had a random bug for 10 minutes I couldn't fix. So I'm just going to leave the code fully working and not rebuild it live. This will all be published on the Forge Bitbucket Dynamic Pipelines Reference Apps repo, which the link for which I will put into the chat now. And let's go through it. So we're going to start in the manifest file, as we always do. So for anyone who's new, the manifest file is where you basically tell the Forge platform what your app does and how it needs to execute your apps. This is a really critical part of how the Forge platform sort of knows what to do. And this is kind of how we stitch all the different parts of the app together. So it's a pretty simple manifest. You'll see here that we've declared a single dynamic pipeline provider. If you were in the last webinar, you'll understand this is basically where we just we tell Forge where the dynamic pipeline provider is and kind of what it needs to call to use it. This is single function. We need some permissions to be able to talk to the Bitbucket repository. And this might be new to some people. We've added this little node runtime label in here. So the new Forge runtime is now in GA. So you do need to add this runtime label under app and then specify the node runtime you want to use. This does have a lot of benefits though, particularly your local dev loop is now like 10 times faster. Actually really cool. You can make a change locally and literally in the time it takes for you to toggle back to your browser and hit, refresh on the screen, we've bundled the change, pushed it up, deployed it, and you're running your, change stuff live. So it's effectively like you're running entirely locally, but inside the cloud product. It's really cool. So nice simple manifest, nothing super fancy there. So what you'll see here though is we have a single function. It's under index.main, and the function is called main. And we have the dynamic pipeline provider module, which is referencing that main function. So this main here, for instance, that main there. So basically telling the dynamic pipeline, call this function, which is in the index.js called main. So what do we have in here? Going up to the top, we have our main function. So this is basically all of the logic of the app in here. So less than 100 lines of code, and that's including comments. And to be honest, my code here is not the most efficient. So we'll walk through how this all works. So the first thing we need to do is just grab some kind of important reference information out of the request. So when the dynamic pipeline provider runs, it receives this request from Bitbucket, and that request follows a sort of standard structure. And it's going to have some important reference information in there that you'll need in order to be able to talk to the Bitbucket API. First of those is the workspace ID, you'll need the repository ID, and then what you'll be looking for is this pull request ID. Now, this won't always be in the request. It's only going to be in the request if the request is for a pull request pipeline. So just make sure you're doing sort of all your null checks and stuff like that here, like I am with these little question marks, to make sure that this is actually going to be there. Otherwise, you'll get a undefined error and your app will crash. Oh, yes, sorry. Font, small. There we go. I need a big button inside IntelliJ that says webinar version. It just makes everything bigger. All right, so once you've got those bits of reference data that you're going to be using to talk to the Bitbucket API, we need to confirm what type of pipeline is being run. So we only want to run selective test execution on pull request pipelines. We don't want to run it on, say, our production deployments, because that would be a little bit silly. You want to make sure you're running all of your tests when you're doing a build and deploy for your production site. Otherwise, you're kind of wasting all of those tests. To determine what type of pipeline is being run, we have this target property inside the pipeline configuration. And inside the target property, there is a type value. So we're just calling this the target type. Now, this could be a bunch of different things, and all the different versions of this are available in the Bitbucket Cloud Dynamic Pipelines reference docs, which we'll throw in the chat in a little while. But what we're looking for is a target type of pipeline underscore pull request underscore target. That is the target type you will see in the request if it is a pull request pipeline. Now, this is an important nuance with this. Pipelines can run for a bunch of different reasons. And you can actually have multiple pipelines running on the same, say, push of code to Bitbucket Cloud. For example, if you have a default pipeline, which is just the one that basically runs all the time, and you also have a pull request pipeline, which will run on any branch pattern, both of these will run on a push to a PR, because basically the default matches everything. And then the push to the PR will match this one as well. So both of these will run. And I'm doing this right now on purpose. The reason this is relevant is because you'll get two requests coming to your dynamic pipeline app when you push code to the PR. Only one of them is going to match this. So this doesn't look at whether there's a PR that is sort of in the system that the pipeline is linked to. What this looks at is which of we call them selectors in the pipeline YAML file was triggered for each invocation. So you will get two invocations on a pull request if you have a default in here, one for the default, one for the pull request. Only one of them is going to pass this logic check here. And that's relevant to the example I'll show you in a minute, where you will actually see both pipelines running side by side. One of them is going to implement selective test execution. The other one is not. It's going to sort of follow your standard, just run all the tests kind of workflow. All right. So we've grabbed the key information, we identified the type of pipeline, and then we're making sure that only ones that are pull requests are going to enter this little logic block here. So what we want to do inside here is we want to figure out which tests we want to run for this particular pull request, and then only run those tests in the pipeline. So to do that, we're going to create a new step for running those tests. And we're going to call the Bitbucket API to see the files that changed on the PR. And we're going to use that new step we created to dynamically select the tests we want to execute. So the first step we're going to do is we're just going to extract the actual pipeline workflows from the request itself so that we can add things into them. So this is just kind of like grabbing the information. So pipelines will always be in the same sort of path in here. So it'll be request.pipelines configuration.pipelines and then pull requests, because we're looking for the pull request pipeline specifically. There may be one of these, there may be multiple. For the sake of completedness, I would just grab all of them and then iterate over them later on and add the step in, unless you only specifically want to do it for one of them, in which case you can then introspect the pipelines and look at the target and see if it's the right one that you're matching against. But for the sake of simplicity, I'm just going to grab all of the pull request pipelines and do this for all of them. We then need to generate this test step. So now this looks nice and simple, but in there there's a bit of logic going on, which we'll dive into in a second. So this test step is the one that has implemented the dynamic test execution logic inside it. Once we've done that, we're going to iterate over all of the pull request pipelines, and we're going to basically grab the actual pipeline itself and iterate over it, and then we're going to add the dynamically generated test step to the end of that pipeline workflow. So it'll just be a final step at the end. Now, you can add it at the beginning, you can add it wherever you want, just for the sake of simplicity, I'm adding it here at the end, but the way you do this here is not super critical. The main thing is that you add it into the workflow. You may actually want to add this earlier rather than later, so that if the tests fail, the pipeline fails faster rather than waiting right to the end. It's just nice and simple. Once we've done that, and this block here has completed, then we're just going to return pipeline configuration object to Bitbucket Cloud. So we can run the new pipeline with that new test step in there. Okay. So that all makes sense. It's all sort of relatively clear. The fun part is this section here, get selective test step. So everything here is kind of just basic logic and workflow. In here is where we get into the kind of the meaty part of this implementation. So the first thing we need to do when we want to generate this test step that is implementing selective test execution is we need to get the list of files that were changed on the pull request so that we can identify which tests we need to run. So to do that, we have a function here which calls the Bitbucket REST API. So you want to specifically be calling the pull request diffstat endpoint. And you want to be using the workspace ID, the repository ID, and the pull request ID that we filtered from the request earlier to call back to the Bitbucket API and get the diffstat for that pull request. I have a little generic handle errors function here. It's logic there basically to handle any responses that are not in the 200 range. I get the response and then I return the values in that response. This is just a pretty simple sort of wrapper around the Bitbucket API function. The key thing is making sure that you're calling the diffstat endpoint. So back here, we have the pull request changes. And what I might do is I'm going to go forge tunnel. I'm going to show you what actually is returned from the diffstat endpoint if my computer decides to behave. I'm having issues with my IDE this morning. I think it's because I'm on like the new beta version of IntelliJ with the new terminal. It's being a bit silly. There we go. Okay, Forge tunnel is now running. So what I'm going to do, I'm just going to log in here. So you can see what this actually returns. And then if I go back, I'm going to just trigger a pipeline to run. 2 moments. Cool. We'll see a pipeline execute in 2 seconds. There we go. And so now what I did is I just made a quick change to the README file in this repository. And so what you're seeing here is the actual what is returned from the diffstat endpoint. I'll blow that up so you can see a bit better. So this is what gets returned from the diffstat endpoint here. So there's a lot of information in there, and most of it you actually don't need. So what I am doing is when I get the changes from the diffstat endpoint down here, I'm just going through and I'm just extracting out this escaped paths property from the new value. Make sure you're getting the new values, not the old values, because you want to be running your tests on where the files are at the point where the commit has been happened, not where they were before, otherwise you can get issues. So go into the new property and then grab the escaped path. So if I go down and I get the get paths from changes, you'll see that that's basically what I'm doing here. I'm just iterating over all of these diffstat objects. I'm going in and getting change.new.escaped path and pulling that out so that we just have this nice clean path here. And I'll get rid of that. All right, so what we have here now is basically a list of escaped file paths that we can now use as part of our logic. So what I need to do here is I now need to generate a test script, which basically tells my test runner, hey, only run tests that relate to the files that are part of these paths. Now, this is going to be different depending on your test runner. I'm using, obviously this is a Forge app, so I'm using a Node.js test runner. I'm using one called vtest. So it's made by the team that make Vue.js, which is the front-end framework as well, and the team that make Vite, which is a JavaScript build tool. Great testing tool, really fast, really efficient. And it has a nice feature where you can pass it a list of code files and say, run all the tests that are related to these code files. You don't need to pass it a list of test files. You can just pass it a list of code files, and it will go and look up the imports in those code files and figure out which test files it needs to run for those code files. Now, a lot of test runners will have this feature built in, but some will not have this feature built in. So that you might need to do it a little bit differently if your test runner has not got this feature built in. So if I go to generate test script, what I do is I do some filtering on all the paths. So for this example, I don't want to run tests if it was the test file itself that changed. I only want to run tests if it was the source file that changed. So I'm excluding any paths that include the .test in the path, and I'm only returning files that have a .js at the end because I don't want to run tests if my README changes, for example. That's not really relevant. And now you would customize this to whatever your particular use case is. You might only want to run it with Java. You might want to run tests if your test files change to make sure those tests are actually working. So you would update this to basically do whatever you need it to do. But what you want to get back here is you want to get back the paths to the files that were changed that you care about when selecting which tests you want to run. I'm then just doing some cleaning up of the string. So this returns me basically a list of those paths. I need them as a single string connected by empty spaces because that's the terminal command that my test runner sort of expects. So it wants me to say vtest related and then a list of paths separated by spaces. So I just create that single string separated by spaces here. And then I just interpolate that into my test script. So this I just got from the vtest docs. It just said, this is the command you need to run in order to do related tests. And then I interpolate the paths for all of the test files, sorry, all of the source files into it here. And then I return that string, which is now sort of got my command to run the test runner. I'm telling it I want to run its related function. And then I path a list of source files I want it to run the tests for. Now, What do you do if your test runner doesn't support this feature where you can just pass in a list of files and it will go and look up the tests? Now, that's going to be a bit different depending on how you've structured your repository. So for example, if you store your test files in the same directories as the source files, so let's say you have the source file and the test file and they're next to each other, then what you would do is you would probably use something like the code search API. And basically you would search for each of the paths for the code files that you're looking at, but you would search that same directory, but looking for test files in those same directories. So you might search for test or .spec or something like that in the same directory that the source files were in using the code search API in Bitbucket. And that will return you a list of all of the spec files or test files for those files. If you have your tests in a dedicated, say, test directory in your project, but the file name matches the file name of the source file, then you would sort of iterate over all the source files, grab the name, and then you might do something like a glob search, again, using the code search API to find all of the test files that match those source files. So how you do that is going to depend on how your repository is set up and whether your test runner supports this feature of just passing in the source files that change and it looks up the relevant tests. If it doesn't support that, then what you'll need to do is basically use the code search API and just find all the test files that relate to the source files that changed. So it's sort of one extra step in the process. And then in that case, what you would do is you would still construct the same string, passing in whatever your test runner is and then whatever its command is. And then rather than passing in the list of source files that change, you would probably give it a list of test files that you wanted to execute. And you'd have to just do that logic around looking up the test files yourself. So it's just one extra step in the process. And that's all completely achievable just using the code search API and Bitbucket. At the end of it, what you need is this string, which basically is going to tell your test runner what you want it to do. So we get that back. This is the test script here. And then finally, we're going to construct the new step. We're going to add it to the pipeline. Now, I just created a little simple class or a step just to sort of wrap it because the structure is a bit nested. So I'm going to pass in the name of the step. We're going to call it selective testing. And then I'm going to give it the script I want it to run, or scripts, plural. So I want to do three things. I want it to install vtest globally so that I have the vtest command I can run in the terminal. I want it to run my local npm install in the project, so I have all my dependencies I need for the project to be tested. And then I want to inject that dynamically generated string I created at the end, which is going to tell vtest, hey, this is the list of source code changes. Go find all the tests that relate to this source code and then run the tests for those changes. I'm going to construct a step from that, which is done down here. And then I'm going to return this new step that we want to inject into the pipeline. I go all the way back up. See here, we now have this lovely little test step, which is what comes out of that. And I just add it in as the last step in the pipeline that was going to be run, like we mentioned before. And then all I do is I turn configuration back to Bitbucket Collab, and Bitbucket Collab will now read that and it'll execute that pipeline when a pull request is created. So I'm going to just create a branch real quickly, and I will show you that working. If I can remember how Git works. Oh my God, that's a commit message. It's early, I'm sorry. We got there eventually. Now, what I'm going to do is I am going to go and I'm just going to add some comments into. So I have some example files in here that I use to for testing. So I have this like function here which just generates the full name. Then I have some tests here for it, and I have some validate credit card functions, and I have some tests here for them. So what I'm going to do is I have some tests here for the API functions I wrote. I'm just going to log something in here so that the PR will just take a change in this file. And so my test runner will look up this file and grab this file to run the tests for. So I'm just going to go. Nah. branch. Let's hop over to the other screen. So then if I go to here, go webinar, demo, create that pull request. All right, so now we're just creating a PR with those changes. So see, we've got the API functions. Now we have some tests that relate to API functions. So what we should see is that the pipeline, we're going to have two pipelines running. One is going to be the default pipeline because that will run on every push. And then one will be the pull request pipeline, which is the one that will implement the selected tests. We'll just give it a minute to pick up. All right, so see, we have two different pipelines running here. I'm going to open both those up. I'm going to open that one, I'm going to open that one. So this is the default one. This is the one that's hard-coded, and this is going to run every single test in the repository. Now, I only have 3 tests in this repository, so I deliberately added some sleeps into those tests to sort of just demonstrate the point. This one here is the dynamically generated one, and we can see this is actually already complete. Even though this actually would have been triggered around about 5 seconds after the other one, because it would have had to go and do the full loop of talking to the dynamic pipeline, having it call the API, and a bunch of other things. So it probably would have been delayed by a few seconds. It's already done. Whereas the other one, the one that runs all 3 of my tests, took roughly three times longer. No, about 10 seconds longer, which makes sense because there's 2 extra tests in there that are sleeping for 5 seconds each. So I'll quickly run you through what happened here. So this is the hard-coded one. So I have my standard step at the beginning, which says hello from the hard-coded pipeline. And then I have the static testing step, which does not dynamically generate tests. And it goes into vtest run. And you'll see here it runs 9 total tests over 3 files, each of them having 5-second sleep in it. And so what you see here basically is it's run all of the tests for the entire repo, which has taken me 29 seconds. Versus if I go to the one that is the pull request pipeline, so this is the one that will have been, will have triggered the dynamic pipeline logic and run the selected tests. You'll see here the test only took 19 seconds rather than 29 seconds. So of that 19 seconds, about 13 of them is the build setup. So pulling the Docker image in and installing vtests, installing my npm dependencies. And about 5 seconds is the actual testing itself. You see here, only 1 file was checked and only 3 tests actually had to run. So the overall time for the testing step went from 15 seconds down to 5 seconds. Now, obviously, 15 seconds as 5 seconds is not that big of a deal. But if you imagine that you have a repository of hundreds of thousands of tests and you have like a 45-minute testing component of your pipeline on every single one of your feature branches, and you could say reduce that from say 45 minutes down to 15 minutes, suddenly that's a massive improvement in your overall workflow because you're now getting your turnaround time much faster. And that's really all there is to it. So I'll go back to the code and we'll run back through it again, but you can see here it's all working. We're picking the tests that we need to run based on the PR. It's reducing the build time. And if I jump back, just run through exactly how that works, and then we'll see if anyone has any questions. So going back to it, what we did, we grabbed out those key bits of information we need to call the API from Bitbucket. We grab the target type of the pipeline so we can confirm if it's a pull request pipeline or not, and then we basically do some logic if it is a pull request pipeline. What that logic is we grab all of the actual pipeline workflows themselves that relate to pull requests. We generate this test step, which has the dynamic logic in it for the selected test execution scripts. And then we add that test step into the end of our pipeline. So we can add it wherever we want, but here we do it at the end. And here again, what we do is we call the Bitbucket API. We get a list of all the changes on the pull request. That's using the diffstat API endpoint in Bitbucket Cloud. We do some string cleaning. We just clean up the strings of the paths to get a list of just straight paths for all of the changed files. And then we use those to generate the script we're going to run in our pipeline to only run tests for the files that were changed. And again, we're leveraging vtests related test functionality here, but you can do it without that just by looking up the paths of the test files rather than the paths of the files that were changed. One extra step in the process using the code search API. We generate the test script. We generate a step with that test script in it, and we return that. And then, like we said before, this test step just gets added into the pipeline, and then we return the pipeline configuration back to Bitbucket, and we're all done. So that's kind of it. We're looking at, I would say there's probably maybe 25 lines of comments, stuff like that in here. So it's like 65, 70 lines of code in total, plus our little wrapper for the API call. So maybe 100 lines of code all up to implement selective test execution, which if you're in a big repository, we could be looking at saving you in the area of like 30 to 40 minutes every single build. So for your developer productivity and overall workflow, it's going to be a massive, massive time saving and a massive improvement in how your teams operate. All right,